Dear friends, we are talking on generator protection, and in the series of generator protection, we are talking on earth faults. We have talked about triple line fault and double line fault, where you can use differential protection system, and interturn fault, where you can use transverse differential protection scheme. But earth faults need a special scheme. In that, we have also proved the futility of current as a measuring quantity. See, the restricted earth fault protection uses current as a measuring quantity. There, the main problem is quite a lot much of winding is remaining unprotected. And in our case, for large generators, we would want to reduce the earth fault current to very low value, primary 2 amperes. So that would lead to no winding being protected for earth fault. So that can not be used. That we have proved. So what you can do? So the another possibility is, rather than current, use the voltage, and that too zero sequence voltage. I have proved in my module 2 of power system protection, which is uploaded on AdaptMe, for which no doubt you will have to pay and see. But third harmonic and zero sequence are synonyms. Zero sequence voltage is always third harmonic, that is 150 Hertz. So on generator PT, there are many windings. There are 3 secondary windings usually, because you see there are many protections. So one of the windings is open delta connected, and this open delta connected, across open delta connected winding, we join the relay 64, which measures earth fault. Very good thing is there you could not protect any percentage, but here you will not be able to protect 100% of generator winding. Unfortunately so, because generator under normal operating conditions, rated operating conditions, produces 1 to 3% of third harmonic. I mean, exact fundamental is just not possible for large machines. It would be producing all other harmonics, that is third, fifth, seventh. Even harmonics are not usually produced because generator is symmetrical with reference to its central axis, but the odd harmonics are produced. Then third harmonic out of that is about 1 to 3%. So you cannot make relay 64 more sensitive than 3%, and therefore 3% winding will still remain unprotected. You can protect 97% of the winding from terminal. 3% from neutral you will not be able to protect. So what to do to protect the complete winding to be protected? The 100% winding to be protected. For that, this scheme is used. This scheme is of relay of Asia. When Asia was existing, Asia is yet existing. Asia Sweden, a protection company, I mean relay manufacturing company, and there was Brown Boveri Switzerland. Both have merged, and now it is ABB. ABB India is also there. In India also at many cities, the ABB is there, and ABB is doing many kind of businesses. One of the important business is relay manufacturing. So this relay is a very typical relay. Across generator PT, we have an earth fault relay which is sensitive to fundamental, and across neutral, we have a relay that is sensitive to third harmonic. But relay is not connected directly. You see, even the grounding reactor is also not connected directly. because you are passing hardly 2 ampere, but that 2 ampere is passing through 4000 ohms. That ohmic value is large. So neutral will go to 8 kV with reference to neutral, with reference to ground when an earth fault occurs. So a reactor which is capable of withstanding 8 kV and very large ohmic value 4000 ohms is technically not feasible. So we are connecting an NGT. It's a distribution transformer, 15 single phase distribution transformer. 15.75 kV is the primary voltage, 240 volt is the secondary voltage, and reactor is connected in secondary. Reactor value is some 0.978 or so, roughly 1 ohm. And if you see it on primary, it will be 15750 divided by 240 raised to square. So it will be to the tune of 4000 ohms, right? So we have connected the reactor as per our requirement, and then we connect one interposing VT, voltage transformer interposing PT, and across that we connect an earth fault relay which is sensitive to third harmonic. It measures only third harmonic voltage. It rejects all other frequencies. Whereas an earth fault relay across generator PT measures only fundamental and rejects all other frequencies. So the detailed scheme is like this, that the relay which we connect across the neutral PT, there are two relays that we connect, 1 and 2, and relay number 3 is connected across generator PT line to line. Number 1 is set for third harmonic because 1 and 2 both are sensitive to third harmonic. Number 1 is set at 3%. That is the normal third harmonic that is generated by the generator. If it crosses 3%, that means there is some fault. Not 0 to 5%, because 0 to 5% it cannot detect. Right? Because it is set at 3%, and when fault occurs between 0 to 5% towards neutral, then the third harmonic voltage will be less than 3%. So one will not operate. If the fault is towards remnant 95% towards terminal, then number 1 will operate, and 0 to 95%, 0% consider terminal, and 95% towards neutral. That trip signal will go and class A trip will be initiated. Now, neutral, you see, why should we at all sense the fault at the neutral? That is very important. Because neutral is 0 voltage, and if 0 is connected to 0 because ground is 0, nothing happens. Generator is not at all damaged. There is no current passing. And therefore generator is not at all damaged. You can run the generator for 24 hours or for as much time as you want. Then why at all should you sense the neutral fault, neutral earth fault? Neutral earth fault we should sense because neutral earth fault is also very dangerous. Not neutral earth fault itself, but if second earth fault occurs after some time, maybe after 1 month, whatever, but then your neutral due to first earth fault is now solidly grounded, and therefore second earth fault will lead to very high current through the generator stator core and very bad damage, very costly damage. Costly damage to the generator repairing also, and costly damage with reference to revenue also. So number 2 is very sensitive, hardly 0.2% or 0.5% of third harmonic, right? So it is very sensitively set. So when the generator is normally working, it is generating 1%. So 2 is operated. 3 is also operated because generator is generating and it is delivering load, delivering power to network. So number 3 is operated. But number 2 is operated means that NC contact is open. Therefore, 95 to 100% trip signal will not pass through. Because generator is normally working. I don't want the scheme to operate. If fault occurs at the neutral, then all voltages are zero. All voltages are zero. Fundamental also is zero. At 2, right? Third harmonic is also zero. So it is less than 0.2%. So it will de-energize. But because fault is at the neutral, generator is working. So number 3 is energized. Number 2 is de-energized. So 95 to 100% trip signal will go. And generator, the scheme will detect even fault at the neutral. 0 to 5% will be detected by number 2 and remnant 95% will be detected by number 1. This is how 100% of the stator is sensed for earth fault. So thus we complete the all types of faults. Triple line, double line we have covered, interturn we have covered, and earth fault we have covered. So further on, we have to cover the abnormalities. There are many abnormalities, and all abnormalities are very dangerous to the generator working. So we will see the causes, consequences, and the protective scheme for all those abnormalities in the next tutorial classes to come. Because we want to keep the tutorial classes small, you can hear them once, twice, thrice until you completely understand the schemes, right? Hardly half an hour's job. If you want to go to the numerical approach, it is something like this. Read V and V0. V is normal fundamental frequency voltage. V0 is third harmonic. Then we ask a question, is V0 less than M? What is M? M is 90% of P. And what is P? P is the third harmonic voltage generated by machine under normal operating condition. That is, M is less than 90% of P. If M is less than 90% of P, that means the third harmonic voltage is less than even that machine is normally operating, then fault is towards neutral. Fault is towards neutral in 5% area, 0 to 5%. If answer is yes, then the fault is there. Possible fault is there, I am telling. Fault may not be there, but because machine may be stopped, machine is not running at all, then V0 will obviously be less, or you are closing the machine. So that part which was done by relay number 3 is done by this section. That is V greater than 0.7 VR. If V is greater than 0.7 VR, then machine is running. If V is not greater than 0.7 VR, then the machine is not running. Then reset the counter and repeat the procedure. If the answer is yes, then increment the counter. We are taking sample usually at every millisecond in numerical relays. So you can have taken 60 milliseconds, that is 3 cycle operation. You can keep 20, you can set the counter at 20 also. Then 20 millisecond after 1 cycle the relay will operate and it will issue a class A trip command. That is one thing. But second thing, remnant 95%. Then you are asking, is V0 more than P? That means third harmonic is more than the voltage produced by normal operation. That means there is fault in remnant 95% towards terminal. If yes, then increment counter. If no, then repeat the procedure. You see, this is the way how you can numerically look at the scheme. In numerical relays, you can program like this and you can set the earth fault. I mean, you can sense the 100% earth fault data. So with this, my friends, I end my talk. But while ending, I would request you to stay tuned with Head-Up-Me, because Head-Up-Me is going to deliver uh, lectures on video lectures on generator protection, remnant part of generator protection, transformer protection, induction motor protection, all uh, sections of power system protection. So if you want to learn, please stay tuned with Head-Up-Me. Subscribe for our channel, like the videos. About 2 lakh views we have crossed. We want to reach to 4,000 view hours. I mean, people are viewing, but they would be just viewing for 2-3 minutes. But if you view fully, then only the view hours will increase. And if you view fully, then only you can understand the idea. Therefore, I would request you to view the video fully. Request your friends also, whom you share, that they should view it fully to understand power system protection, because I am trying to share my knowledge. So you spread it further. You let it go to more and more people. Till then, my dear friends, thank you and goodbye.